Yes, dear students, from previous knowledge of vectors, I told you that when we add two or more vectors, the resultant is 1. We get one vector when we add two or more vectors. Conversely, a vector can be supposed as sum of two or more vectors, and these vectors which give rise on addition a single vector are called components of the vector. You can understand if I add this f1 and f2 and f3, so you get what? f1, f2, f3. So now this resultant f, this whole vector f equal to sum of f2, f3. So that way a vector can be supposed as sum of two or more vectors. These vectors which when added to give vector are called components of vector. And that way we can resolve, resolution means to break. We can resolve a vector into two or more vectors. And those vectors which we can break a vector are called components of vector. Now here, for sake of simplicity, we take the component vectors which are along x, y axis, even z axis also, but initially we will take for components of vector along components of a vector along x and y axes are called Cartesian components. Cartesian components. We need these components to solve and to understand many problems. This is very important to understand why do we resolve components. So suppose here this is vector r. We represent vector r and its tail lies at origin of x or y axis. Here is the origin, it is the x axis, this is the y axis. And vector r, this is origin O, this is P. OP is the line of action and we can represent the vector r equal to vector OP. Makes angle theta with x axis. OP is vector r, this is x axis, this is y axis. It is simple if you understand addition of vector. If we draw perpendicular from head of vector r to x and y axis, then we get these 2 points. Suppose it is A and this is B. So OA and OB are two components of vector r along x and y axis. OB is the component along y axis and we write it as ry. OA component of vector r along x axis and we write it rx. I think there is no need to write anything on the board. You can listen to me and make your own note or read the book. My purpose here to explain what is the meaning of components of vector and how to obtain components. So simply I told you that it is vector OP is vector R. We want to find two components of vector R along x and y axis. So we draw perpendiculars on x-axis and y-axis, which meet the two axes at point A and at point B. Here OA represent vector R x, which is component of vector R along x-axis, and y ry along y-axis. You know, this is a rectangle here, and opposite sides of rectangle are equal and parallel. Opposite sides of rectangle are equal parallel. So OB equal to PA, AP, and we can write this is also vector RY. So that way we can write here the vector R equal to RX plus RY. Simple, but we are many times interested in magnitudes of vector. So what is the relation between magnitudes of vector Rx and R? I told you that magnitude of R, simply if we write it in modulus, it is magnitude R. Rx modulus equal to Rx, and modulus Ry means Ry. Use of trigonometry will help you here to establish relation between Rx, Ry and R, and relation between magnitude of vector R and Rx, Ry. From figure, base upon hypotenuse cos theta. So modulus Rx upon modulus R is equal to cos theta. And using this fact, we can write that Rx equal to R cos theta. This is the magnitude of component along x-axis. Magnitude of component of vector Rx along x-axis in terms of theta and R. ठीक है भाई? Now similarly, Ry this, but Ry this also. So modulus Ry upon modulus R, perpendicular upon hypotenuse sin theta. Dear student, please learn trigonometry, very important for physics purpose. Actually nowadays we will try to find out shortcuts. But in that finding shortcut, they go long cut. They don't remember where we can write. We have got a convention, and I don't want to take the name of that convention. I know we have to learn base upon perpendicular cos theta, perpendicular base tan theta, perpendicular hypotenuse sin theta, base upon hypotenuse cos theta. कुछ भी नहीं जाता इसमें. Hardly take very small time. Or simply Ry is equal to R sin theta. This is the magnitude of component of vector R along y-axis. Now, don't get confused. The component of vector become scalar by reading this thing. Na? We have determined here the magnitude of component of vector R along y-axis. Component of vector is again a vector. I initially told you sum of two or more vectors gives one vector, and those vectors which give one vector are called components of vector. So component of vector is again a vector. Here I have established the relation between magnitudes. Here I have established relation between magnitudes of vector Rx, Ry. Now, if I square both the sides of equation 1 and 2, squaring both the sides of equation 1 and 2 and adding them, we get Rx square plus Ry square is equal to R square cos square theta plus r square sin square theta. Or simply it is equal to r square common cos square theta plus sin square theta. Sin square theta plus cos square theta is equal to 1. And hence rx square plus ry square is equal to r square. Or you can write here simply just r is equal to under root rx square plus ry square. So that way, if two vectors are at right angle, then magnitude of resultant will be obtained by this equation only, rx plus ry. नहीं है वो वेक्टर r नॉट इक्वल टू rx plus ry का मैग्नीट्यूड बराबर नहीं है. Magnitude of r is not equal to sum of rx and ry magnitudes. They are at right angle. It is vector addition. So now what is this angle? How to find out this angle? From trigonometry again, if you see equation 2 and 1, from here modulus of ry upon modulus of rx, modulus of ry upon modulus of rx, whether you see from here tan theta, or you can see here it is sin theta upon cos theta, which comes out what? Sorry, rx, ry upon rx comes out tan theta. Or you can write theta equal to tan inverse ry upon rx. If vector r is three-dimensional vector, so it may have z component also. So like this case, अगर if I think like this, अभी ये हमारा एक क्यूबाइड बना हुआ है, क्यूबाइड. This is the origin O. ये x एक्सिस, ये y एक्सिस और ये z एक्सिस. So this is vector r है. R has three components. One is rx here, this is ry here, and rz this way. Here we cannot show because of the limitation of two dimensions. But if you know rx, ry, rz are the components of vector along x, y, z axis, so what you can write? The vector r equal to rx I cap plus ry j cap plus rz k cap. So rx, ry, rz are the magnitudes of components of vector r along x, y and z axis. I hope you have got it very clear. Components कौन हो, which what are components of vector? Parts of component, the vector which when added together give one vector. Then those vectors which are added together to obtain one vector are called components of vector. I think it is very clear. Now why do we resolve vector? What is the need of that? I will take in next video. Thank you.